Hello, good afternoon, everyone. So yeah, I'm Simone Bocca from University of Trento, and within the interoperate project, it was responsible to the semantic tools and the overall methodology for the data sharing and for the data interoperability. And this presentation is about the work that we have done. I would like to start again introducing a bit the context of the project once again, but maybe more related to a data sharing point of view. So it's a patient-centric context, as you already know, in which the patient has, first of all, the possibility to get her own data from her own personal, her own hospital. So with the objective to be fully in control of her medical health data. We are talking about data represented in a formal way following the FHIR standard, including both codes and medical concept expressed formally, but also a long text that can be translated also in the moment they are uploaded on the patient mobile phone. Another feature, another of the context of interoperate is the possibility to download this data on another hospital in a different geographical context. So this context needs the translation of the data that are previously uploaded on the patient mobile phone, and maybe with the possibility of other extension of such data. So including local extension after a visit, after an emergency visit, and different kind of medical data that another target hospital can add. Moreover, the last, okay, no, too much. The last scenario that we already introduced is the possibility of the patient to be a participant of a research study. So as a voluntary and anonymous participant in a research study defined already by research centers, and in which we would like to automate as much as possible the possibility to check the entry criteria for a given citizen within a given study, and automating the data query over the health data of the patient, and the conversion and translation services required by the study, the research study itself. So this is the context in which we. Sorry. Okay. There are already some existing solutions supporting such a context. First of all, the national, so local and international standards regarding the data, both regarding terminologies and coding systems to express formally the medical concepts included in the data. We are talking about SNOMED, CT, and ICD, and LOINC. Those are the ones that we experienced in our project, as well as also information models. So we are talking about structural, how to structure the information that we want to share through the data sharing approaches that we propose in interoperate. Those standards are actually widely used, and their usage is increasing nowadays. The fact is that it's still limited because, of course, it's easier to develop a custom and context-specific solution than define a general methodology, general approach, maybe implementing and supporting fully a general standard, for example. Another existing solution from a more technological point of view, of course, we have terminology servers supporting the standards that we mentioned above, ETL tools that are for conversion, for translation of data, for data mapping. Here, they are also widely used. We have different options regarding these kind of tools. The fact is that usually they are single tools. They are isolated and purpose-specific tools that most of the time they have to be included in the process in order to execute and support the scenarios that we discussed regarding interoperate in the first slide. So okay, the challenges that we want to address within the interoperability that we try to address in the interoperate project are the fact that adopting standard is an hard job to do, due to the fact I was saying before that building ad hoc system is easier respect to implement a general solution. Adopting, for example, FHIR, that is a more general standard. The healthcare is evolving in the data itself, is evolving in the tools used, in the technologies, and even if in the healthcare itself. So the knowledge we have about healthcare is evolving. So we need also systems, tools, and libraries, and all the technology supporting that is able to evolve and to support such an evolution. Then we have one of the most important challenges in our project, that is this trade-off between automation and precision. So automation, of course, is something that we want to improve as much as possible, but with automation, we have a reduction of precision. And we know that in healthcare field, the precision is something that we want to achieve, and we want to reach at almost 100% if it's possible. And this is not possible with a fully automated systems, but we need to reach this high level of precision, the support of human input, so the support of human experts. The fact is that having human expert within such kind of processes does not scale if we have to manage a huge quantity of data. So we have this trade-off between automation, precision, with the support of the human, that we need to find a solution that is able to scale up. These are our challenges for the project. We proposed an approach within the project that is in the next slide, if it will appear. Okay, that we call deep semantic integration, that is focused on exploit as much as possible each value, each data value, or maybe better, each portion of informations carried by such data values, in order to understand such information, made it explicit, and represent that in a more formal way and language independent manner as possible. An example here, for example, starting from Italian prescription that is represented through the data, in this example, through a natural language text, how through this first step of our approach, the objective is to construct, technologically speaking, a knowledge graph composed by, in this case, two different entities. So FHIR medication, that is a resource provided by FHIR, and the medications connected to another kind of resource provided by FHIR, with the relative attributes. So first of all, we extracted a schema from this data, and the relative attributes. Each value of those attributes is then represented formally through a specific coding system, such as SNOW-CT, ATC for the drug, and UCUM for the unity of measure, for example. This is the first step of our approach. The next step instead is to try to extract information from the knowledge graph. Knowledge graph, in this case, is what we have to represent, to have interoperable data. We want to extract data from this structure in order to be used in a specific context. For example, in this case, this second step that we call the adaptation of what we produced. We want to produce in these concrete examples a French version of the Italian data in input, extracting the data that we already formalized in the knowledge graph. This is our approach, concretely represented by this example. And this is instead the architecture and the overall methodology, a top view, an high-level view of the methodology. With the two phases, the in-depth understanding and the in-depth adaptation, with the creation of the knowledge graph in the middle, starting from local data, so data coming from a context-specific, a local context, arriving in the end as output with FHIR interoperable health data, supported by different components and technologies, like the information extraction, the data transformations. Okay, here in the animation, there is first about the description of the knowledge, but let me explain all the components before. So I was saying information extraction to get information from the inputs, the transformation of the data, of the information obtained after the extracting them from the input data, the support of terminologies and schema about thanks to the standards that we included as knowledge. I will describe that in a minute. The translations and thanks to external services, third-party services for translations, terminology mappings, and language generations with training models using natural language process components. We have, on support of all these components in the architectures, a huge base of knowledge. With knowledge, we means all these different components that you can see in blue. So terminologies about coding systems, schemas, standard schema for representing data, not only FHIR, that is our solution for interoperable data, but also local standards adopted in a more specific context, like CDA for the Italian case in FTGM, some EHR for the Belgium hospital instead. Language models, that are the models that we use to train the components for extracting natural language information and structuring them. Rules to map the different representations of the information in the different specific context to a common schema that is the one based on FHIR. And in the end, of course, some different portion of code in order to transform and manage the data for data management, formatting, and cleaning the data set that we receive in input. We should have here also some explanation of all the different components that I already provided. Yeah, so that is the architecture. So the technological point of view of our approach. There is the other part, as I said, we cannot exclude the human supervisions, and in particular, we have two different roles about the human interaction in our process. A knowledge manager that is in charge of maintenance, of maintaining all the different knowledge base, the different components of the knowledge base that I described, and the data managers that is instead the person in charge of supporting the data mapping and the conversion and translation process. In order to have a good interaction between our approach, so the technological part, and these two roles, human roles, a crucial role is played by the tools that we want to use in our approach. One of them, come on. I think it's stuck now. Okay, as I said, the tools they play a very crucial role in order to to create the connection between the human supervision and all the technological part. One of the key tools in our approach is these data mapping tools that we heavily exploit during the project. This is a ETL tool that we at University of Trento extended with multilingual information extractor and knowledge graph building features. Actually, some of the most important features of these tools is the possibility to extract a different portion of information starting from an input. The input in this case is the first blue column on the left side, and all the brown color are all the different portion of information extracted from that string in the beginning. Thanks to this subdivision in different values, we have the possibility to formalize those values. For example, extracting concepts represented as codes in a specific coding system that are the blue cells, for example, for the drugs from the unit of measure. And one of the if not the most important features of this tool that is not presented completely in this slide, is the possibility to map all the different columns here to the common schema, the one expressed on FHIR. So actually, these are all attributes of the entity expressed in the knowledge graph that I showed before. So we experienced in the project over different natural language text, for example, the extraction of prescription from Italian and French data sets. In Italian, French, Greek, and Romanian, also the translation of codes. The translation of codes both in, for what concerns the natural languages, but also conversion and translation of codes regarding terminology and standard codes adopted, for example, from more locally used standards like ICD-9 into more international one, like, for example, ICD-10 for the same standard, another version. LOINC and ETC for Italian and French, while the others for different hospitals. We experienced in managing local, just for conversions from local standard schemas into international standard schemas. So from, for example, CDA in Italy and some EHR in Belgium into FHIR, producing in the several FHIR resources that represent completely the interoperable health data provided by Interoperate. So in the end, in conclusion, and actually what we learned from the experience of the pilot during this summer, we understood that a full interoperability is very hard to achieve, and due to the evolution of the healthcare, it will be always the case, because of course we have standards, we have tools that are necessary, but they are not sufficient to fully cover this gap. We still need an experience in a methodological experience, a kind of innovation more dedicated to the methodology that we have to apply, both for what concerns the technological point of view and the human support point of view, because it's still crucial, this intervention from human. In specific, from the pilots, we have the support from local data expert provided by Fondazione Monasterio and CHU de Liège. The methodology expert represented by University of Trento, and the standardization expert also, support provided by the Fraunhofer Institute for all the profiles developed in following the FHIR standard. Actually, we discovered that even if our approach that is focused on the development of models and rules for knowledge and data mappings, that is requires a huge effort maybe in the beginning, but we discovered that for further execution, it is lightweight to maintain, and thus it's possible to it's a possible solution suitable for the evolution in the healthcare that we discovered as a challenge during the project. So that's it. Thank you very much.